combination of renewable energies and fossil fuels power our cities, our cars, our homes, and our lives. While we cannot predict what new innovations in energy may come, we can predict that the conversion of energy will become more efficient. Let's begin with the equation E equals mc squared. Einstein drew a roadmap for our future. He showed that the amount of possible energy inside any amount of matter can be found by multiplying the amount of matter times the speed of light squared. The speed of light squared is an enormous number, so even a single grain of sugar could, if converted perfectly, be sufficient to power your body for your entire lifetime. Unfortunately, our current methods of converting matter into energy are far from 100% efficient. Very far. Pick up the apple beside you and take a bite. Your digestion, for example, converts 1 in 10 billionths of a percent of a food's possible energy. Toss the apple into the marked area. Let's see how industrial energy compares. Burning coal converts 30 billionths of a percent of the possible energy of its mass. Man-made nuclear, also known as the fission of uranium-235, converts 0.08 of a percent of the possible energy stored in uranium. To break past the 1% efficiency barrier, we have to look at what is theoretically possible. Here are several promising, if distant, options. Not too close now. Best to observe from a distance. A black hole spins at near the speed of light. The outer edge of a black hole, called the ergosphere, accelerates matter to near light speed around its circumference. If you accelerate particles deliberately into the ergosphere at just the right angle, it would be possible for the black hole to accelerate the particle without swallowing it. The particle could then be recovered with more energy than it had previously. Pick up the particle accelerator next to you. Good. Now give it a try. This spinning black hole engine, if harnessed, could convert energy at roughly 29% efficiency, or 365 times more efficiently than a man-made nuclear reactor. 29% is not bad, but why stop there? Let's check back into our graph. As we reach further out into the limits of scientific theory, we encounter the energy of antimatter. This is a normal atom. Notice how the electron is on the outside and has a negative charge. It circumnavigates the proton and neutron in the center. This is the antimatter version of that same atom. Antimatter is the inverted form of an atom. Anti-electrons behave like electrons but have a positive charge. Watch how it orbits the exterior. Its charge is reversed. Antiprotons, in turn, are protons at the center but with a negative charge. When antimatter comes into proximity with regular matter, the atoms will try to sort themselves out. Reach out towards the atoms and press the grip buttons to grab them from a distance. And now try pulling them closer together. Good. You're starting to see. Pick up the spoon and hold it gently. If we had an abundant supply of antimatter, which we do not, we could produce all of the energy we could ever want or need. The teaspoon of anti-water you are holding, mixed into a swimming pool of regular water, would unleash the energy equivalent of 200,000 tons of TNT, or one hydrogen bomb. That's enough to power the world's entire energy needs for about 7 minutes. Tilt the spoon. Let the antimatter fall into the water. Let's check back into our graph. Close to 100% matter-to-energy conversion. And that's the best that scientific minds can imagine, at least for now. What would your life be like if you could survive on just a single grain of sugar? It may take decades, if not centuries, to harness these new forms of energy, but it pays to know how far we've come and the journey that lies ahead.